Facebook.
Hello, welcome everyone. This is the New Year 2022 Live with Nassim webinar. Thank you all for joining us. We have another wonderful opportunity to get to ask Nassim some questions and probe some of his vast repertoire of knowledge here. And it's always very insightful. I hope you are all looking forward to it as much as I am. So if you have a question, please enter that into the Q&A section, not the chat section. So questions go into the Q&A, and then there's a voting mechanism for the questions. So if maybe you don't necessarily have a question, but you see one that you would like to be brought up for discussion, you can give it an upvote, and that'll bring it up higher on the list. There's always more questions than we have time to answer, so it's really a good way to get some of the most interesting questions into the discussion by voting them up. And then in the chat section, go ahead and feel free to say hello and tell us where you're joining from. We have people from literally all over the world who join in on these calls, and it's just so wonderful to see the community that we have that comes together to bring forth these new ideas that are going to really have a strong impact on the world. And it's a community effort to make the kind of change that we're doing. So we're all in it together. And so I'd like to say hello to Nassim, bring you on and see if there's anything you'd like to share with us all now that you got us here.
Thank you, William. It's always good to do the Live with Nassim every month and connect with the people. And there's always such amazing questions. And it's always great to talk with you, although we live and work in the same place. Typically we're doing research and we don't get to talk often. So this is an opportunity to actually take a break from the daily routine and talk with you as well. And so I'm excited about this live. I'm excited about being in 2022. It's all one long day and one long year, but and at the same time it's great to feel that we're following cycles, although the natural cycles would be a little bit different than the cycles we're following on Earth due to the way we've set up our calendars and so on. We're still following the natural cycles, and these cycles, they are they're not linear cycles. That means that, and I mean that in the sense that they're not circular, they're elliptical. That is, that they change as we move forward. They have a evolutionary path in space. Like, we're counting the year, with the rotation of the Earth around the sun and the days and the rotation of the Earth on itself and so on. However, all this is moving in space, making elliptical motion through the structure of space. And although the mechanical motion is currently in the standard model divorced from the information network because of the way current physics are written, but in unification physics, those things come together, and the mechanical function are actually the foundation of the information network. That is, the information is being transferred through the space because there's fluid dynamics, there's mechanical, electrical motions, polarial and toroidal motions, and all this. And I mean, I could get in details there, but what I mean to say is that we're a moving field of information, leaving information on the structure of space as we evolve. And so I think we're arriving at a very culminating moment for humanity. And 2022, I believe, is going to be a very important year for humanity, and 2023. And I'm really happy to be there with you and doing all this together and going through this together.
Oh yeah, that's such a profound way to look at it. That it's not just like a cycle where you're going back to the same point you were at. That's kind of how it's typically thought of. It's like orbit of the Earth around the sun, and because it's actually, as you're saying, it's spiraling through space, and then that's a pretty mind-bending thing to think about. That it's actually, there's information dynamics involved with that. That since you're spiraling, it's kind of part of the evolution and development of the system that you're in, and therefore us and our society and civilization as well. So the new year.
Yeah, and you can imagine even deeper level of relationship of information, because it's paralleling in the galaxy, which has multiple angular relationships, meaning it's spiraling in an arm that itself is spiraling, right? And that arm, and it's spiraling in that arm, moving away from center. So it's the cycles are changing, even in like terms of its motion, mechanical motion across the equator of the galaxy, right? So it's about 30 million years for it to do a half turn, equator to equator. So 60 million years to do a full rotation. However, that's changing as it's going away from center. It's getting longer. That cycle is getting longer, right? And then this is rotating along an axe, which is the center of the galaxy, right? So that's the polarial flow. I'm sorry, the toroidal flow of the motion. And then that motion as well has a polarial relationship to the information transferred through the center, the nucleus of the galaxy, and then the information expression of the center of the galaxy, which is like a plane of electromagnetic radiation that defines the equator. Yeah, so it has, and all these things, every single one of them have an impact on the local environment of the solar system. And these impacts, although may be of very long nature, meaning like very long cycles, for the galactic structure, those are very, very short cycles, right? And so you can, when you think about time and you think about the way we think of time, if you think of it in terms of fractal dimensions of scales, relationship, then you start to get a sense of, what would be like, what is a resolution to like one of the big problems in physics, which has to do with the frame of reference and, observer-observed relationship. The frame of reference has a problem in standard model because of a fractional issue, which is mentioned by Sutskin and others, like, for instance, for the Schrodinger's equations and so on. And
the Schrodinger like cat paradox, like
right.
it's the observer that's supposed to collapse the wave function, but then what about all the other frames of references that are involved in that kind of situation?
And fractally, the fractional problem is that you can, which frame are you taking and which scale are you taking the frame at? Like, so the observer, what do you mean? What about like the flea on the cat? What about, the bacteria in the box, whatever, like,
Yeah.
there's many frames. But even in Einstein field equation, more technically, there is an issue in which, the relationship of the frames of reference produce singularity, mathematical singularities that are not resolved in Einstein field equations, which has to do with taking the proper frame. So taking when we say the proper frame in physics, we mean it in a very specific way. We don't mean it in like, oh, there's a proper ultimate proper frame. Just that the proper frame means the frame of reference of the particle falling into the black hole, right? So the object instead of the observer observing the object falling into a black hole, because as far as relativity goes, if the observer is a frame of reference, which is typically the frame of reference that has been taken historically, which is not the proper frame, the observer, basically sees the particle freeze into space and time at the surface of the event horizon, because the Lorentz, goes to infinity. In simpler term, space-time goes to infinity. So, time gets very long because the particle is approaching the speed of light. And eventually, it gets to a point where no signals are emerging from the system because it's superluminous. And this is a problem in the standard model as well. That has to do with Hawking radiation. I'm trying not to be too technical, but I'm just, it ends up producing a fractional problem that is more known as the hyperplancks, or, sub-Planckian problem, which, like, all of a sudden the information would have to have some Planckian wavelengths, but if you take the proper frame, then the particle is just continuing to accelerate, and there's no singularity at the horizon. There's still singularity in the center of the black hole, and so you still have a gravitational well that's accelerating the particle. And so to arrive at sub-Planckian level, then you have superluminous speeds, and now you have the function that actually describes in unified physics, not in the standard model because they haven't made all those links, which, anyway, which basically shows clearly that, you would have a superluminal speed to entanglement, meaning that entanglement is not some weird animal of quantum theory. It's the information of the structure of space-time moving at subliminal speed. So and so this is a really important point because as well, and I know I got technical here, but it's a good thing for people to know this, because you could think of it as well as like consciousness, like in terms of philosophy for the layman, that's listening to this going, why, is this something I should care about? But, or, I mean, certainly in physics, it has a large impact that this has not been understood, that it's not been completely solved and so on. But, and it is solved in unified physics. But the main thing is that to remember there is that there is fundamental entanglement. So if we're thinking of, our relationship to everything, we're embedded in these rotations, we're embedded in these mechanics, the mechanics of a particle falling into a black hole, for instance. And, the fractional problem tells us clearly that that structure has superluminal speeds and massive amount of information, right? And and that the structure of space-time, the fabric of space-time, has a very clear mechanical dynamics in terms of not only as a gravitational component, meaning the gravitational component of space-time is not only like okay, let me put it this way. So space-time in physics currently is taught as a fabric that's generally neutral. I'm going to call it like that. They call it flat, unless there is mass energy in its region somewhere. And there it curves. So space-time is not tied in the dynamics of the mass itself. Meaning,
because you have mass and energy. What is mass and energy, right? In this situation.
Exactly.
Yeah.
And the concept that there is space-time out there that's flat somewhere is incoherent with observation. There is no such thing as a place where there's no energy or mass. There's always energy or mass, whether it's at the particular level or it's at the larger scale of where you're observing. You're inside a gravitational field everywhere. And there's gravitational waves everywhere. And so you're never in a flat space locally, right? And whatever flat space you define is always in relationship to the scale at which you're defining it. The curvature might be very, very, very slight over a distance between the sun, inside the universe, for instance, but it's never completely flat, and so basically flat space then gets curved by mass. However, the stress energy tensor part of the equation, which is the mass part, the source of curvature, right, in Einstein field equation, is actually not undefined, meaning it's defined in terms of its kinetic and potential energy, but not mechanically, meaning not like understood what mass is, right? This is why Einstein said, the metrical side of the equation I've got, but the tensor part, the stress energy tensor, it's like sand in my hands, I believe was his expression. Now we have a solution that shows that space-time is involved in producing the mass, in the first place, showing that this energy, what we call energy mass, is a function of space-time spinning. Like it's a mechanical fluid dynamic function of space-time. And that is really, really critical. It changes a lot of the way we think about time and space and our relationship to it. And it resolved this fractional problem because you realize that the fractional problem is a fractal problem in the equations, meaning that you know, the scale relationship has to be considered in the frame of reference. So, you know, there's scale relationships, mechanical relationship in the scales that drives one to the other because it's one fluid that's spinning, making vortices everywhere. And depending on the size of the vortices, you had different scales. And so what we call mass is space-time spinning, and thus space-time spinning and time have a very fundamental relationship to existence, matter production, the evolution of the universe, the evolution of a galaxy, the evolution of a star, the evolution of a planet, the evolution of an atom and a human being, you know, a cellular structure, the evolution of a cellular structure, the change that's continuously happening, like even locally, like for you, for instance, making millions of cells every seconds, you know, by cell division, changing the local information. Like the whole thing is continuously oscillating and moving and evolving and changing and growing and transforming. And that, you know, so all of a sudden you see the universe more as a live thing, which is a thing I think you like to do, William.
Oh, yeah, yeah, the living universe. Yeah.
Yeah.
Because you know, in a fractal system, you know, living things such as ourselves are coming from living processes. It's
Mhm.
like you can take that all the way to the dynamics, mechanics of the universe at some of the most fundamental levels.
Yeah, and all of a sudden you realize that thinking about the universe mechanically doesn't mean that it's boring and linear.
Oh yeah, oh,
It's a
not at all.
beautiful fluid of evolutionary dynamics, and you know this fear to describe the universe mechanically, and this division that happened during the early times of quantum mechanics, where all of a sudden, you know, it was assumed that the quantum level could not be described mechanically, and it can't. It just has to be described, you know, in fluid dynamics, and then
Mhm.
it's correct. You know, it's very much correct. And and it actually outputs, you know, if you do it correctly, as we did, you know, if it's correct, it outputs the Navier-Stokes equations, which are our current fluid dynamics equations, like from first principles. It comes out of it, and which is nice, you know, which is like $1 million price right now, actually. So, you know, but the yeah, so you know, and so it's beautiful, it's incredible, it's powerful, it's energetic, and the technology you can build, you know, to just, you know, instead of putting your turbine in the fluid dynamics of water falling down from a lake, you know, you can put your turbine in the fluid dynamics of space-time. It's very much, you know, it's much more efficient. You know, the water got in that lake in the first place because of the fluid dynamics of space-time in the first place, which spun the earth and produced weather systems and all this, and eventually, you know, condensated water into your lake, you know, and put it there for you to extract the energy. It's one way to extract the energy. You know, it's crude, but you can imagine that if you understand the fluid dynamics of space-time, you can make an electromagnetic turbine, if you'd like, that produce the same effect, except that the structure of space-time has velocities that are much, much higher than, a typical mechanical turbine that we use for hydroelectric power production. So, there is a good application for life actually to continue living, because the universe is a living universe, and the proof is that we're here living it. I can't wait to write that paper with you. The paper we're writing right now, that we started on, is unifying biology with all of this, and those mechanical dynamics are found at the biological level with the little motors of the mitochondria.
The ATP synthase, we've got pretty much all the same key ingredients for this kind of energetic dynamic, all the way to the spinning plasma. There's the spinning proton plasma that's driving those ATP motors, those Brownian ratchets.
Brownian ratchets, yes. That was Feynman, wasn't it? Yes,
Yeah.
right, very good. Yeah. So yeah, I mean, there's direct relationship to these understandings and these physics. And of course, all this cellular mitosis and all this stuff that's happening is happening in a fluid we call water, right? And the fluid dynamics of these little motors spinning at 8,000 RPM, or at 60 if you're running a marathon, 60,000 RPM. You can imagine the fluid dynamics that's going on inside that structure.
And I always like to go back to trying to consider when these things first came about, the emergence of these things, because it's such a complex system. I mean, these are the ATP synthase motors are veritable nano machines. How they came about in the first place. There had to be a pre-existing condition, which was probably the space-time dynamic that was existing kind of in a pre-biological context, that the biomolecules were able to kind of couple to that information structure, that energetic gradient in space-time, and kind of bring it to another scale, the biological scale.
Right. And so that it could eventually start eating space-time directly, indirectly as well, meaning indirectly, like through, protein exchange and so on, and proton exchange, electron exchange, and all this stuff, so that there would be an electrical potential in the structure of space that we call, a biological entity. It's an electrical potential in space, if you'd like to think about it that way. Right? Because there's an electrical potential, like a capacitance across the membrane of the mitochondria that is very specific to, and so that's driving fluid dynamics in space-time, and so the thing starts to eat space-time, but and then it assembles in more complex things that eventually eat space-time, and we call it eating, right? We actually put, atoms in our body, and remove atoms from our body, and we there's an energetic process that goes along with that has a clear thermodynamic effect, right? Like we're burning at 100 degrees Fahrenheit approximately, continuously for some 100 years, hopefully, and so it's really like, when you think about it at the most fundamental level, like you do, then eventually you start to think about it in terms of like the amount of information that's moving through the system and the thermodynamic effect that it does. Which brings me to, something that happened this month that I thought was kind of funny, or last month, I can't remember when, but not too long ago, which was that Veritasium, which is a great YouTube channel, that treats physics questions in a layman manner, made a video about, Maxwell's equations, and what they say about the electromagnetic field, mostly the magnetic component, and the source of it, and a famous Feynman lecture about it, where Feynman says this theory is completely insane. What words exactly? I was paraphrasing.
Yeah, he says just to really drive home how nuts this theory is.
Right. And
so our crazy theory.
Yeah, our crazy theory, yes. And so, which eventually says you're gonna have to ignore that part, just make like it's not there. Well, that part, which is similar to the part of the frame of reference I was talking about earlier, is the fact that charge doesn't come from the wire, meaning like charge is somewhere outside the wire and is going into the wire. The thermodynamic component locally is not conserved, meaning there's a conservation issue in terms of where did the energy come from. And and then there's a flurry of videos, because Veritasium is very well known. There's a flurry of videos from engineers, contesting, saying even Feynman ignores it. You can't ignore it. It's not. Although it's the way, although it's the way it works, it's not useful to think about it.
But for practical purposes, let's just keep thinking about it with the wrong model.
Exactly.
The way it's actually not working. Well, for practical purposes, we'll just keep and keep telling everybody that that's how it's working when that's not exactly how it's working.
Exactly. Not in many different ways too. In engineering, like all kinds of ways, or just bad interpretation of Maxwell's equations, and that have been put into conventions at the engineering level to like keep it so that engineers don't have to scratch their head, and they can just say this, that, and that gives that, right? But not actually understanding that those are not the mechanics of space-time. They're not the mechanics of Maxwell's equations, which demands that the charge emerge from space-time or the field, or something that's not the wire.
And it's really not a harmless thing to describe it and talk about it and teach it in the incorrect way, saying that the energy and the charge is flowing in the wire, through the wire, because it's actually really important and critical that even the engineers and the students and everybody understand that the energy is flowing through the field, the energy is coming from the field into the wire, into your appliance. That's going to, that conceptual change is going to have a huge impact on how we develop further technologies. You're going to develop them with the understanding that this is a field interaction. It's
and so basically, just to say, that insistence on ignoring the field, just as a parenthesis, is why vacuum energy is not our current source of energy.
Yeah.
Right. So maybe we could have ignored it for the engineers, but the physicists, should pay more attention, or pay attention. And this is something for the last 25 years, 30 years, I've been trying to bring awareness to in the scientific communities that, although we use these equations like Einstein field equations, we use Maxwell's equations, because they're not unified. We don't have a unified model of how like this all works together. These little pieces that we ignore, like the problem of the frame of reference, or the problem of, the source of charge. Conservation laws are important laws in physics, like the fact that you can't say where the charge is coming from is a problem. And but interestingly, Feynman lecture clearly shows that in the context of Maxwell's equation, however, in the universal way, it's conserved, meaning that if you consider the scales that are global scales of the field equations, so if you include the field, basically, which was the way Maxwell meant to write these equations, meaning he wrote them with an ether, what he called an ether, and so when you include the field, that is, when you include the global relationships, then you have a source and it's conserved, right? So the conservation laws hold, and so that's really, really important, because it's a very important concept that has to do with scaling relationships and mechanical scaling relationships. And so we've solved all this in our equations, so that it's clear, right? So that it's properly defined mechanically. And now you have, and now you have a mechanical source for charge, right? It's clear where charge comes from, and the mechanics of it and the math which are fluid dynamics. So, the engineering approach is still valid in terms of utilization. It's just that when you utilize those equations and you're wanting to have the maximum amount of efficiency in a system, or your intent is even to extract energy from that field, that you have a field to extract energy from. Otherwise, you don't. So of course, you don't attempt to extract anything. You're just moving charge, along a wire. Now, the fact that the charge is following the wire and producing electromagnetic, electromagnetic and thermodynamic effects, that like the impedance and the, capacitance of the wire and so on. These, are become really critical notions, that would make you engineer device in certain ways.
And even, the understanding it from a fundamental physics perspective, and the way that the field is bringing in the energy, it seems like it would just make it so much easier to transition from, this utilization of energy via electromagnetism to gravity, because it's kind of the same principle that you create a gradient, a gravitational gradient, and energy is going to flow in the field. Just like with the electrical circuit, you create an electrical gradient and energy flows via the electromagnetic field. So it's like, seeing that these are really unified principles. You can apply it almost equally to electromagnetism as you can to gravity. Because they're operating under the same unified principles.
Correct. And when you're moving charge across a wire, the wire itself is made out of the same components meaning you're dealing with fluid dynamics. And so same thing when you think of mass, right? And energy in a region of space, curving space-time, right? You can think of this mass as like a flow of space-time, not separate from space-time, that's curving, not divided. It's the same thing. It's just different states of the same thing. I was thinking about it the other day, how to explain it to the layman. Like for instance, and this is very clear, we make these boxes. So for instance, water can be in a fluid state, it can be in a solid state, and it can, so I should have started with a solid state, a fluid state, or a gaseous state, or even a plasma state, but that's another thing. And so when you think of these phase transition, it's all different things, right? Like fluid doesn't look like solid. They look quite different. By the time water freezes and makes crystals, it's very, very different than its fluid state. And then if it evaporates, it's different again. And so in gaseous state, it's different again, but you wouldn't say that all these things are different things, right? You would still say that's all water. It's one thing that's in different phases. So just like the dynamics of fluids in space-time have different phases because of the energy levels involved in that region, because of its, and thus its temperature and so on, right? So you're gonna have both phases where space-time, is like a solid, and it's everything is moving in unison, and in like collective behavior is very, very coherent, and so it'll look more like a solid. And then if and then at the edge of that solid, because it's spinning, you're gonna have phases where it's much more fluid, and you're gonna have phases that are very high thermodynamic phases, and so on. And so you can actually start to describe these phase relationships of space-time as one thing, not, and that one thing at all scales, meaning it fractalizes. So what I'm describing right now, for instance, can be a star, or could be an atom, or like a proton, or could be a galaxy, or it could be, a galactic black hole, or it could be, a Planck, right? So all this is, it's hard for, like without showing you the equations, which are gonna be soon, exactly how that's described, but clearly, it's nice to see that the scientific community, through actually layman, articles and videos like Veritasium, which I love because he really goes for what's true, and one of the videos he's done is a good example of that, where he talked about this little device that has a propeller on top, and that accelerates faster than the wind, the calculations that were done, that and then the engineering world saying that's not possible. So clearly that's not the case, although the equations clearly showed that that would be. Then I think he made a bet.
Yeah, a $10,000 bet with a professor. So I think like a university in Nevada or something.
And then there was multiple engineers that got involved and were supporting that view and all this. because that's the common view. You can't have that. It's seems like a violation of the conservation of momentum, and so on. And so, but he won that bet, and so it made a lot of noise. I think it got over 10 million views or something. So it's nice to see that, from this kind of information, just people being honest about what's out there. It's not a dig on the scientific community. It's just that these things have been there, like, mm, you know, um, inertia is another thing, that's not completely well addressed in physics and all this. And if you're trying to unify physics, then you really want to look at the parts where we don't understand very well. And when you look at the parts where we don't understand very well, you find that these things are very fundamental. Like, we're not talking about some dimensions of strings or anything. We're talking about very clear, like mechanical things and electromagnetic things, charge, motion, all these things. And so if you want to understand how to put it all together, you have to look at these things that are not obvious to the standard model, and then see how they relate to each other. And then when you look at the way they relate to each other, you'll find a mechanical path, to why this doesn't clearly, like define this, and why this definition can be defined better if we include this other thing that we don't understand very well, and then it all kind of starts coming together.
It's really interesting because all the pieces are there, all the knowledge is there. It just needs somebody to kind of take a step back, which I think you've done. Take a step back, look at it, and start putting the pieces together in a logical, coherent picture, and
Right.
It comes out actually very elegantly.
Yeah, and it's really simple, and I mean, relatively simple, meaning like it's not like it's not like 10 to the 500 dimensions of strings, right? So the thing is that it's really difficult in the context of the educational institutions to be able to, like, there's a tendency to want to, like, ignore the stuff we don't understand. That, of course, that's not the goal of science, and good scientists, and there's plenty that don't think that way. They look at the hard problems. But in general, that's the elite of physics, and the mass inertia of all the other physicists is a tendency to ignore these things, which means that even the people that are thinking about it are having a hard time getting the information to percolate through the institutions, so that these thoughts can be thought, right?
Yeah.
So basically, an engineer could ignore Maxwell, and do all its engineering without it. An engineer should know about this, about Maxwell, that in such a way that there's a consideration of developments, possible developments of well, what if we considered this? What would it, like, would it change in our philosophy about energy and charge, and what is an electron?
Yeah. Well, when I saw Feynman's lecture, and what he was saying, had a very large impact on my view of what's happening in the biological system. Because I mean, we're describing all these capacitors and movement of charge, resistors, inductors, and all of this kind of stuff in the mitochondria, for instance. But then when you start thinking about, well, what the Maxwell equations of electromagnetism are saying is, like your energy that's being acquired in the mitochondria via the ATP, that's coming from the field. That's acquisition of energy via the field through these mechanics. It really, I think, was enlightening for myself on conceptualizing exactly how the energy utilization is occurring in the biological system, and just the extent of the field-like nature of the interactions of the cell, the
It's
subcellular
fascinating.
systems.
It's fascinating. For instance, I mean, it's basically making water, correct?
Yeah. Because that proton plasma, free protons. It's there's a gradient. They're getting shuttled through that ATP synthase motor, and then they're getting attached to the oxygen that we breathe in, and you get water, H2O. So this motor is, producing water. Our energy production is producing water.
Yeah, it's remarkable. It's a remarkable thing. And this might sound really esoteric in the context of our conversation right now, but there's people that have been known to not eat and not drink, for very extended periods of time. We're talking years, and be monitored in scientific facilities, and they're recycling all their fluids, and they are living off the structure of space. And some of that material that was measured is public. Some of it is still classified. It'd be nice if it was declassified one day, but it would be so I think there's examples of this. So the idea that like we're completely relying on the material world that we ingest is not a complete picture of the energy production in a body.
Because in a sense, the food is kind of a derivative of that space-time energy. Because like you were even saying, like eating space-time structure, the food is kind of a derivative of that. You could bypass that and go straight to the source.
Correct.
And what we see in the actual cellular and molecular structure, that is possible. I mean, it's already doing it to a certain extent.
Correct. Well, it's doing it because charge comes from the field, whether we like it or not. That's what it says in the current equations. Although it's a crazy theory, I don't think it's that crazy. Actually, I kind of disagree with Feynman. I think it's quite sane. It is crazy in the sense, and I understand in the sense that Feynman said it in terms of like conventional, theory. But I think it's pretty clear. It's in some ways, when we consider what is charge more fundamentally, like what is an electron, or what is the charge of a proton, and we discover that it's fluid dynamics of the field, then it's quite sane, right? Oh yes, okay, fluid dynamics, basically you get the fluid dynamics of space-time to move around the wire, and charge emerge, right? Like and you get those fluids to move by moving electromagnetic fields, right? So meaning like an electron doesn't travel along the wire, you know, it,
At all. Oh,
at
well, I
all.
mean, like barely. Like,
Right.
yeah,
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 if at all.
yeah.
That's still debated.
Well, and in the AC, I mean, it's just wiggling back and forth, right?
Right,
Yeah,
correct. Yeah, exactly.
yeah.
And so you have to think about it in a completely different manner
Mm.
than the typical, there's a pipe with electrons flying through, that you're calling the wire. And it's not that. There is a flow, but the flow is coming from the field into the wire, which is producing a thermodynamic effect in the wire. And yeah, so it's a completely different way to think about it. And it's the correct way because clearly it gives the correct answer. I mean, Maxwell's equations are very, very solid like this. Yeah. So, yeah, so the same thing for the biological structure, it's extracting from the field and we're seeing the flow, right? We see the flow very nicely, mechanically in the fluid dynamics because it at the cellular structure it's easier to see it. And the energy production is significant. It's uh, you know like your body weight in ATP in one day, uh, you know, about a ton of ATP if you run a marathon that day, so it's significantly good energy factory, it does the job very well. 100 degrees is non-trivial thermodynamics, so uh it's like keeping water under boiling almost conditions, for almost 100 years. Uh, so anyway, we should get to questions. I've been babbling for a while.
It's been really great, really interesting to hear some of these new discoveries, new insights that you're bringing.
Mhm.
It's really great to get to explore some of that with you.
Yeah, thank you. Yeah, it's fun.
Yeah, but we definitely have some very interesting questions. Um, there's definitely more than we'll ever hope to answer in the short time that we have together here now. But see, there's one at the very top here from Oriana. And she's talking about a podcast that actually we did together on World Water Day. That was with um, the professor at the University of Washington, Gerald Pollack, with we were talking about water, some of the physics and importance of water to the biological system in particular. She asked, she says, I heard you speak to water being the first form of life. Could you speak to how water first forms from plasma and how water holds memory?
Hmm. Yeah, that's a good question. Can you bring her on?
Yeah, so let me bring her in.
Then there was a good question as well from Jeff. Got 10 votes.
I don't see Ariane on anymore.
Okay. All right. Well, so yeah, I mean, so, like, in order to answer that question, I got to go back to the creation of our local universe. But you know, I don't know how far back she wants me to go, but you know, in order for water to be produced, it has to have a thermal fusion engine nearby. Oh, there she is. Hi. Oh wait, you're muted.
There we go.
Hi.
Hi, and this is my friend Tina. We met at Resonance Academy. She's from Sweden, visiting.
Oh,
here.
wonderful. Hi. Where are you?
Hi,
Hi.
wonderful
Nice
to
to
meet
meet you all. Where are you guys at?
Tucson.
Tucson, Arizona.
Got it. Yep.
Right
She says
on.
it's Swedish summer here.
Oh yes,
Our
Swedish
winter
summer.
season.
That sounds fun. Yeah, the oh, we lost Jamie, I think. Um, so yeah. Oh yeah, you're at the living place of Lucifer. Mhm. Yeah, your local telescope, binoculars, courtesy of the Vatican. In any case, yeah, your question is a good question. Are you a biologist?
Biochemistry.
Biochemistry, okay. So just so I can aim it the right way. So, you know, molecular interactions of hydrogen and oxygen happen in, you know, very specific layers of fusion engines, which are black holes in the universe, meaning the molecular interaction. So for instance, if this is true, what I just said, then we should register water coming out of the sun, right?
Water coming out of the sun.
Yeah, we should be able to measure water emission from our sun. If water molecules are produced in fusion engines, which our sun, you know, produce at the horizon, the source of fusion is a singularity in the middle of the sun, but that's another story. Then we should have, you know, molecular emission, right, of water out of the sun, and we do. So, and we've known that for almost 20 years. I keep pointing it out, but in general, that's another thing that's ignored. And basically, there's quite a bit of water that comes out of the sun, but as well, there's plenty of water all around. But then you have to ask as well, the source of carbon, the source of silica, you know, like the source of things in order to make a planet. And we know that that's produced in what is called supernova explosion, you know, that like the table of elements, the elements are generated in that sense that there's cosmic dynamics that are occurring to produce these things. Now, again, the standard model of, you know, molecular production in the universe is missing. It's like chunks, and that have to do with how that comes in at the first place to produce a supernova, right? It's missing the source, which is the black hole. I'm trying to give you a short answer. You're asking a deep question. Because you're asking a question about chemistry at the most fundamental level. And chemistry is very ill-defined. It's not like in current scientific paradigm, chemistry is very loose. It's very loose science. It doesn't have, you know, there's many things that are not addressed or unsaid because the physics is not present to support it. It's not, you know, for instance, you know, ion bonds and all this stuff. Like it's not, because again, charge is unknown, you know, the source of charge is unknown, source of electromagnetic. So there's all kinds of things. But so when you plug these holes and you put it together, then all of a sudden you have a direct chain of event from the production of particles at the horizon of a black hole, right? Matter creation. And then, you know, the eventually molecular structure becoming you know, defined in terms of masses and relationships of orbitals, right, of both protons and electrons and so on. And you have eventually, you know, a molecular structure that will, you know, continually produce the same result, because it's continuously the same ingredients, right? And one of these results is the water molecule. And that water molecule then, you know, is part of this flow of information that started. It's entangled, right, with this whole thing, right? It's one thing, right? And so you can imagine now I can actually, you know, literally, I mean, formally, that is with formulas, you know, map out the information flow, right, that produce eventually a water molecule that's going to interact with carbon molecules and other molecules and start producing more complex systems. And these complex systems are going to continue to, you know, because there's conservation of energy, this conservation laws, right? The conservation of information, it's going to continue to make more complex systems that have similar dynamics, physical dynamics, but that may be more gross because they're in larger systems. They're farther from quantum scales.
Can I ask this then? So the proton has a singularity,
Yeah.
correct? Okay, and every singularity has a spin, counterspin, feedback, feed forward. So what I'm wondering of this, this water molecule with the protons having those singularities and the spin counterspin, is this spin counterspin of the molecule itself some way involved in the memory that water would hold?
Oh, I see. Yeah, sure. Yes.
Feedback, feed forward would be part of the whole construction of not only the molecule, but the memory that it would be able to record. And part of what I'm really working with is the spin counterspin. And what it appears to me that the spin is the spiral out expansion of the universe. The counterspin is all the movement, that's all one movement, returning to the singularity itself. And in that,
Yeah,
in
the tendency,
encoding.
yeah, the tendency is to try to generalize and simplify, but you can't. You can't say the mechanics are more complex than that, meaning that for every spin, there's a counterspin, meaning for every bit of information that's moving out of a system, there's a bit of information that's moving in. That's why it's conserved.
Right. So that part I understand. And that's why I'm wondering if this spin counterspin is somehow involved in all that water flows around the planet in the atmosphere. If all of that spiral out is the counterspin at every scale, including every proton within the molecule, that compressing in is the encoding of evolution, learning of itself.
Yeah, and it's not local. So what moves in is what you're describing moving in. That is the gravitational field or the mass of the system, right? So it really is important to consider that. So the information, right? The information is encoded on the structure of space. Remember, charge is coming from the field, right? So so that means that the memory that water holds is not in the water.
Right. No,
it's in the space. What you're structuring is the space, and the water molecule is aligning to the structure of space, right? So you have to keep it in the right order. Otherwise, you make the same error that engineers make, right? So the space is what's holding the water molecule. So for instance, in DNA interaction, the water molecule holds the DNA information, right? In its correct configuration. That's why Montagnier was able to like reconstitute a DNA strand, right, in pure water, just by holding the information in the water electromagnetically, right? So, I'm trying to answer your question most clearly. It's a complex question, so but I don't know if it's helping what I'm telling you. It's just that so when you think of the information being in water, you have to remember that water is not a thing. Water is atoms, you know, that are interacting, and these atoms are subject to the field geometry.
Right, but what I'm also considering is that there's singularity, there are points that are holding the spin, counter spin within each of the atoms of each of the molecules. And is that accessing then the space in which the memory is being exchanged?
Yeah, well, each of these atoms are accessing the space and producing, like each one is doing that. And then the larger relationship of this information, you know, is the water molecule.
Right.
You see, so you have to always go through the scales. You can't isolate, right? So each atom is holding information, and the relationship of these atoms in the space defines a set of information as well, right? So if you want to change it, you change the space, right? And
Right.
then
But what's informing then the actual molecule is there information coming from the 0 point within each proton?
yeah, of course, the proton is an information factory. It's made out of plunks, each one being one bit of information, and they're flowing in a colloidal and toroidal matter. It's a little fluid dynamics of itself, right, of space-time. And so that's what you're calling a proton, and that's what you're calling an electron. Electron is the flow around that proton, and you know, this all thing is a flow all together. And then
So there's an exchange of information with the physical world and the non-physical.
there is no such thing as a separation between the physical world and the non-physical anymore. That's the idea. That's another thing. I was listening to Deepak Chopra the other day, and it's really important that we stop making this this division that between the material world and the non-material world. There's no such thing. There's only a field, and that field has different phases, and one of the phase we call material, that we have divorced from the non-material, but that's an illusion. That is the illusion.
Does the material world in a sense coagulate out of the non-form formlessness?
Yeah, it's the same. It's the fluid dynamics. It's the fluid dynamics of that field. Let me make it more clear. Okay, imagine. Okay, imagine that you're looking at an atom and you're looking at the fluid dynamics of the atom, right? And you're saying you're not thinking about. So you're thinking of a frame of reference of which is you looking at this thing flowing. Okay. So you might say this thing is this thing over there. I'm going to call it matter. Okay. Like an atom, like a proton. And I'm over here, I'm in the space. Right. And I'm separate because this is the space and this is the non-space. Okay. Never mind that, like, if you look at the atom, it's actually 99.99999% space, but never mind that. You're only considering the charge that you're seeing, because that's all you're seeing is charge in space, right? So, but you're calling it an atom, and you're thinking you're free of that space. However, you're inside a solar system that's inside a galaxy, that's inside a universe, and all that spinning, and you know, and so you are part of that field, meaning, you know, there's no place where you can say I'm not matter. So for instance, if I zoomed out and I was super big, right, and I looked at the universe, it would look like an atom,
Mhm.
right?
Right.
And what you're calling space would be what I'm calling matter, right? So the true non-dual, and I dislike that term, because when you say non-dual, you already created duality, because if there's non-duality, anyway. But let's just say unification, so this is better word, right? Unification is when we stop making that distinction between, right?
Mhm.
Same thing in charge, right? As we were discussing, like the field, charge comes from the field moving. Charge is not a thing that somehow magically appears and makes wire heats. Okay, so do you understand what I mean? So when you think about the water molecule as the source of life, you have to think of it as a fluid dynamics of the atoms that makes it,
Mhm.
right? And these fluid dynamics transferring information from, you know, and that transfer of information producing charge relationship that makes a water molecule, right? And then that transfer of information at the larger scale can all of a sudden water molecule and carbon molecules start to interact, right? Now there's more information being distributed on larger scales, you see?
Mhm.
And then, you know, again, you know, like these molecules interacting with others to eventually produce fluid dynamics of a mitochondria that is transferring, you know, energy, literally, right? And ETP, you know, across boundaries, producing charge relationships, you know, like you know, capacitance across different parts of space that are getting bigger and bigger. The information still being transferred at all these scales, right? It's conserved, right?
Yeah, I understand the conserving of the information. I'm still wondering if the water molecule or the water itself that holds memory
Mhm.
and it's being held in the field itself, or it isn't held in the water molecule. This
Wait. When you say that holds memory, this is what I'm trying to like distinguish for you. It's space-time that's holding the memory.
right, that's what I'm getting to.
Yeah.
The space-time is holding the memory, but what is that mechanism is what I'm getting to. What is it that's actually the space-time holding memory?
But
It
think
is-
of it, that's what I was saying. Think about it as you know, a structure in space. So
Right, so what is that? What's structuring space?
mhm. What's
Think of
structuring
it
space? The
that,
mechanical movement of the information flowing through the system.
okay,
Yeah, so information is the position of a coordinates at any scale. So you don't you can fractalize to infinity, relative to the rest of everything, of the rest of the universe, multiverse, whatever. Like that coordinate is getting a set of information that's very specific, whatever scale you pick, right? It's observing the universe from its own very specific relationship, right? Do you understand? And all these scales assemble, all these frames assemble across scales to make more and more complex system. You're asking a deep question about the source of the nature of information. And
yeah.
yeah, and that is, that's the beautiful thing, is that in a fractal, you know, universe, holographic fractal universe, each point is the center. So each point observe. So this is why all humans are humans, but we're all different, right? Not one human has the same digital print, not you know, iris, everything is different, but we're all humans, meaning there's a global, it's conserved globally, but locally it's not.
Yeah, so you have the coordinates you were saying. So each, in order to have the information, you have coordinates. So wouldn't a coordinate require time as well? So a
Yes,
location.
its position requires time. Yeah.
Time.
Yeah,
So
because
that's
it's an
how-
evolutionary path, right?
So that's where I'm curious of how time is held as memory, like a rhythm, a rhythmic pattern, like
Oh,
a
yes, it's pulsating electromagnetically, right? It's circulating. When I'm talking about circulation of space-time, I'm talking about, you know, electromagnetic pulsations,
right.
fluctuations of
And
space-time.
that would then relate in scale to the celestial rhythm of the moon, the stars,
Right.
the galaxies, everything
Of
spins.
the rotations of all
Rhythm.
these objects. Yeah. Yeah,
Right,
yeah, it's
it spins in
conserved.
rhythm. What
Yeah.
I'm looking for is there a fractal pattern rhythm that would encode the intelligence of evolution such that you could recall the entelechy of evolution. Where's it going? What
Yeah, absolutely. That's what I'm saying. Yeah, that's absolutely right. The information is conserved as I was describing it locally.
Uh-huh.
Meaning, no, it's not conserved locally in terms of thermodynamics, but I just want to, it's conserved, meaning that like you can follow the path of information locally,
Mhm.
or you can follow the path of evolution from the beginning of the universe. This is why I started answering your question saying I would have to go back to the beginning of the universe.
It happens in every moment.
Yeah, which the beginning of the universe is a nonlinear thing, so there's not really one of those. It's just that I could pick a beginning, right? We'll pick the local universe that we're in right now as a beginning, right? But that, you know, is part of a larger beginning. That's part of a larger beginning. So so you could follow the information from that scale, or from the local scale of the information coming out, right?
On the Planck scale,
Yeah.
right?
And meaning that each bit is a different set, right? Because it's observing the universe. So for instance, you can say, I've observed the universe, I'm one set. So I would have to pick a coordinates in you, right? And I could say, well, it's the atom in your belly button because it's close to your center of gravity. So I'll pick that one. But then, you know, or the cell near your belly button. But then I would have to pick which, you know, out of 100 trillion atoms that make up that cell, which one I'm picking for the coordinates of your center of you, right? And then, you know, when I pick that atom, then I would have to pick which proton, and then I would have to pick, you know, which Planck in that proton. There's 10 to the 60th Planck in that proton. So there's like trillions and trillions of Plancks I could pick to be the coordinates, right? So I would say probably the one that's at the center of that centers that proton, but then, you know, they would be the sub-Planck, and, you know, this is the fractional thing. So that means that any complex system, or any system, is always made of a compilation of frames of references that is observing the universe from their own and contributing, right, collectively to that entity, right? You can always find smaller frames or bigger frames, right? So, you know, so whatever, like, especially for life, you know, if you're asking, how does life emerge from a water molecule? Well, now you have the mechanics of how the information moved through the scales, right? When I say that, I don't mean just philosophically or as a nice story of how the, I'm meaning formally, you know, in formulas. You have the understanding of the mechanics on how the information is moving through the scale. So you have the understanding of the mechanics of the nature of life, right? And so that means that you can structure the space so that the water molecule maintains a high coherent information flow, so that the cells don't start dehydrating, right? Because mitochondria slows down, and don't start making copies that are not so good copies, which we call aging, right? We gotta stop this aging thing, because it's kind of an inconvenient to disintegrate and reintegrate and disintegrate and reintegrate all the time. So it's easier to just stay integrated and then just keep getting wiser.
Okay, so yeah, so I get that, and the wisdom of an acorn to hold not only all the trees that have gone before, but all the trees to come forth from it.
Correct.
And what I'm really looking at working with is what's the pulsing rhythm of this unfurling, unfolding pattern.
So it's very specific to the resonance frequency of the entity that you're trying to measure, right? So meaning this is why we're all a little bit different, right? So
right,
yeah.
but we all have a thumbprint. It's
right.
unique to us, but we all have one, which means we all had
We all have a thumb, yeah, hopefully.
Opposable thumbs.
Yeah.
So that's what we're looking for, is that what's the rhythmic pattern that holds one cell becoming a multi-celled being,
right,
going to 8 billion years, and we do it in 9 months.
Right.
What's that fractal of a rhythm?
So are you asking if I've calculated that frequency? I could. I haven't done it for biology. I've done it for atomic structures.
Okay, that's helpful. Yeah. I haven't calculated it as much as I just feel it and follow it. And I'm tracking the celestial rhythm that's the fractal pattern unfolding within us as well.
Well, the rhythm is, there's many rhythms. I think it's important, again, you have to always think about scales.
Right.
So if you observe a certain rhythm of information transfer for biological structures, for instance, they're involved in a larger rhythm, which is the Earth spinning around the sun and the moon moving and all this stuff, and the way water is flowing on our planet and all this stuff. So these embedded rhythms all are related to each other in terms of harmonic relationships,
right.
Which produces our reality. So this is why those equations are important. This unification equations are important, is because you actually start to understand the harmonic relationship between scales and the information transfer. And, it leads to the birth of a whole new civilization, because, scales become a way of relating, not a impedance to our evolution, meaning that there's a lot of energy at the quantum level, and there is a lot of possibility of doing very important exploration at much larger scales than our planetary surface, if only at the solar system scale. So for instance, if you move your coordinates, your frame of reference, right, to the solar system, right, so you move your body to orbiting Jupiter, your experience of reality changes fundamentally, because you're having a new relationship to all the parts that are around you. And so you're feeding different sets of information to your molecular structure and your frame of, you see how, it's literal what I'm telling you, it's not just philosophical, it's literal.
If we actually identify with the universe as our rhythm and become more fluid in
It would be good for people to start to identify first with the biosphere at their rhythm, because it's closer to them, which most people miss. And this is why humanity
Biosphere,
has a hard time unifying, you know.
right, but still, the
I-
biosphere is a fractal rhythm of the universe, right?
Sure, yeah, but this is the closest rhythm, right? And then it would be nice if we adjusted our calendars and all this to actually follow that rhythm, but that's another story. Then the natural rhythm of the galaxy is a really good thing for somebody to integrate. That means they have reached galactic being capacity. But I've said this in many times, so I'm going to say it again, but it's important that, like, to relate to something that's past the, you know, the galactic, past the local environment, right? So to go from one scale to another in our awareness
Uh-huh.
of rhythms,
Mhm.
we have to go deeper and deeper in our awareness of rhythms within us,
Yeah.
right?
Right, yeah, but both are simultaneously.
Otherwise, you have a bogging problem in the information. There's a bog rate. If you know a little bit of network, a bog rate is basically how much information you can push through the thing, right? So imagine that the biosphere is a amount of information, okay, a number,
Okay.
right? And
Okay.
imagine that for your awareness is the frame of references that you think of you, right? Only the coordinates of you, like the, you know, the cell I picked in your belly button is the only thing, you know. So already, like, if you realize you're made a 100 trillion cell or 50 to 100 trillion cell, and you've integrated that many more frames of reference instead of just one cell, right? So now you're all these frames of reference, is this bundle of frame of reference of you, right? That is enough set of information for you to be able to map to all the information that's the biosphere.
Okay.
You see? So
Mhm.
now you've reached higher scales of information by going deeper into your awareness of you.
Mhm.
You don't think of you as one thing, you think of you as a, you know, 50 to 100 trillion cell. Now, right, so now you have more capacity of information, right? So, but now you go, okay, well, each cell is made of 100 trillion atoms, so 100 trillion more frames per cell for the, so now you've multiplied the information by 100 trillion multiplied by 100 trillion. You've gone from cells to atoms. So now you experience your whole self as all the atoms in your body. And again, these atoms are not statics. You're losing some and you're gaining some, and, you know, you're making new cells, and you're, you know, but so this dynamic thing of information flow is like not just your cells, but the atomic structure of your cells, right? So now you've been able to map to enough information for the solar system, right? Because now you've got a trillion, 100 trillion multiplied by 100 trillion. And you can continue going down like this and up,
Mhm.
so that you can go down to the Planck level eventually. So you can get down to the proton level, not just the atomic level, right? So you get down to the proton level and then map to the galaxy, and then get down eventually to the Planck level and map to the universe. And that's why these equations, these scaling equations I'm talking about actually work, you know, is because I can map Plancks on the surface of the universe and get the right mass for it. And I get the, you know, all this actually works out formally. right? I'm not just talking philosophically. Okay. So, so, the reason I was telling you this is that, so the rhythms are embedded within each other, right? And so, all the rhythms are in harmonic relationships. There's very specific relationships. That's why you can write equations on it. You know, if it wasn't specific, I would be screwed. You can unify this, right? But it's specific. And so locally, it looks different, but globally it's not, meaning, yeah, you know, all humans are humans, all planets are planets, and all stars are stars, all galaxies are galaxies, you know, like they have very specific scale relationships, right? Like between galaxies and stars, there's scale relation, there's nothing in between. Like there's stars and there's galaxies and clusters and superclusters. They're very specific, these harmonic relationships.
Right,
Right.
that is a rhythm, and that,
And these rhythm, and you're part of these rhythm and these event horizons, and so you can access all of these from any point, because any frame is embedded in larger you know, reference frame that are embedded in larger reference frame, so from any frame you have access to all the frames, right? From there's no discontinuity, although as a whole the thing is a discontinuity because it's a singularity. It has infinite nature, right? You know,
yes.
this is
the
another
whole
issue.
thing. It's
Yeah,
the whole that holds the whole. Okay.
yeah, it's the whole that
Yeah.
holds the whole. Yeah, exactly.
Okay, speaking of which, I'm going to say thank you very much. And solstice was my 9th anniversary, and so my husband and I got entangled
Oh, awesome.
crystals,
Awesome.
and he loves it. He's not really into science so much, but he loved this crystal. So we're having a
Right
good
on.
time. So thank you so much.
I'm glad.
They
I'm
hold
glad.
memory, and then the water holds. And what we do at night is put our crystal in, and then put them by our nightstands, and it creates a field over us.
Uh-huh.
Yeah, no, it's wonderful. And he's an organic gardener, so we're going to start doing some experiments, William.
Oh, right on. Right on.
Okay, thank you so much.
My
Appreciate
pleasure.
you all.
Thank you. Wow, I took some time on this one, but it was a deep
Okay,
question.
good.
I get in trouble.
You guys were getting into such interesting concepts. I didn't want to interject,
But
even
I'm
though,
sure you had a lot to say.
yeah, but oh, that's really fascinating. So, moving on down the list, we have Jeff Colebrook asking about fusion.
Yeah.
So fusion as the new energy source versus 0-point energy. So billions and billions are being spent in many decades of research. Monster machines are being built, for instance, in France, in China. China just reached 126 billion degrees Fahrenheit for 1,000 seconds. Is fusion a realistic source of energy? Is 0-point energy a more realistic energy source? Given the same commitment as fusion, would the results for 0-point be quicker and more economical?
Oh, yes. Well, let me just say, this is a pet peeve. Hey, how you doing?
Great to be here. Wow, what an honor here, watch unification happening in real time.
Oh, thank you. Yeah, well, I'm gonna try to stay nice and polite. I'm just gonna say, no, it's not that hard, but I'm just gonna say that so far, fusion devices and the trillions of dollars that have been spent to build them since the last 4 decades or approximately since we've been, building tokamaks and Z, Z machines and so on. I have not produced 1 watt of usable power, and have definitely consumed trillions of watts, and gigawatts of power. And, the idea that fusion, the error is in the understanding of what thermodynamics are and the source of charge, again, and, and the geometry that's being utilized. So this can, I don't like the term free energy because it should just be over unity, or over unity is not a good term neither, because it doesn't violate conservation laws. It's not over unity. It's just extracting energy from the structure of space. So there's a source. It's not like magic. And is it a shorter path? Well, I would suggest, just based on my experience and the research I've done, that the shorter path to something is definitely the path in which it has been discovered, some 100 years ago, meaning that there's many devices that have been, brought forward that have succeeded at, energy production from the structure of space. And that, including famous ones, that show anomalies, at least at the minimum. And I just, okay, I'm gonna stop there because I'm gonna get in trouble. But I'm just gonna predict that within the next 2 years, that's gonna be well known. And fusion devices will be, thought as like, an era of exploration of physics that cost a lot of money and that didn't produce the result we were hoping for. There is ways to extract energy from space-time locally with very little thermodynamics involved. You don't need the surface of the sun, or millions of times hotter than the surface of the sun, to get there. Fusion, the concept of fusion itself is not well understood, and that's one of the problems. Yes, you can extract energy from space-time in a non-thermodynamic, in a very low thermodynamic, event, and have something that's quite practical, meaning like it will be on your tabletop and it will power your house, right? Or your car, or if your car doesn't have wheels, it will propel your thingy. It will, that is the path. And the reason is that, again, if you don't know the source of charge and its relationship to thermodynamics, as in the relationship of Maxwell's equation and Einstein's equation, you cannot see how that path is going at it from the wrong end, right? The thermodynamics is the result, not the source, right? And so the source is the field interaction, and the thermodynamics are the result. However, you can see that the field interaction is very, very efficient. It has very low entropy, meaning, there's a lot of the field of interaction that occurs in order for the sun to be that hot. But we don't need all the energy of the field interactions of the sun, right? to produce the energy we need locally. You understand what I mean?
Yep.
So that means that you can produce these field interaction of space-time, extract energy with very little heat produced, very little, thermodynamics. You don't have to contain huge energy events, in terms of thermodynamics. Do you understand what I mean?
Yeah, and I just thought this was an important question for you to bring out and make that point.
Yeah.
That's why I wanted. The question was so people can hear this beautiful, the truth, the answer.
Right.
So,
Right. Well, I'm sure a lot of physicists out there or engineers are going to say, "Oh my God, he doesn't know what he's talking about." Again, like it's nice to see. First of all, I'm speaking from experience, but it's nice to see that, like, we can, that it's emerging. It's getting more clear for people. Like I was saying about that Veritasium video, that the public is starting to realize as well. Okay, Einstein field equations and Maxwell's equations, say things that are very important, that shouldn't be disregarded, right? Because until recently, the reason Feynman had to do a lecture on Maxwell's equation to explain to the scientific community that what they really say, right? The scientific community knew, like at some level, like some of the physicists, of course, but I'm just saying that, like, in general, in the educational structures for people to understand, like, that there's parts of these equations that are not understood, or completely ignored, which in Einstein field equation, people would have a tendency to say, "Oh yeah, there's part of Einstein field equations that we don't understand, like black holes." But in Maxwell's equation, it's commonly ignored. It's thought that Maxwell, in general, that electromagnetic and charge, the source of charge and electricity and all this, that's known, that's well engineered and well known and all this, and it actually isn't. And when you say that, and for the last some 20 decades, like when you say that, in general, it was not well understood by the average physicist, right? So only a few physicists understand it, and the average physicist just basically ignore, that component because it's not necessarily useful, right? They're just solving equations, and so it's not useful to think about it unless you're trying to understand the source, the fundamental mechanics of charge, which as soon as you understand these mechanics, now you have the key to extract charge from spacetime, from the field, because again, it's not an electron flying through a wire. It's just not, and so as soon as you understand that, then you have a source for electric power production, and you can power your civilization with it. And then you stay away from technologies in which you have to produce huge amount of energy event and dump huge amount. In fact, when you succeed at this, now there's no input power anymore, meaning you're just things are oscillating on their own, right? There's no input power. There's like the energy production is directly from space-time. when you start the flow, there's energy to start the flow, but when you start the flow, then it flows. The energy that's flowing is powering the device, and the device is producing the energy flowing. It's in a continuous feedback, which you're not going to obtain with a fusion device, as it's being built right now.
Good. Well, thank you. That was great. And so it's already out there. It's just a matter of if there was $1 billion put towards that, it would be available very shortly.
Much less, more like 250 to 500 million would do it. Yeah, so it's much less.
Tiny compared to what they did on fusion with nothing so far. Interesting. Well, thank you very,
Yeah,
very
it's
much.
just that the money, the resources would have to flow in the correct direction, but yeah, the thing is the information is known. I mean, Tesla did quite a bit of work on this, and and so did Maxwell. So it's all really there, and it just requires an effort from the financial structures and the political structures of the planet to make that happen. I'm hoping that by publishing the physics I'm publishing, that the world will go, oh, okay, here's the engineering path, let's go, right? I'm hoping, it didn't work for Maxwell. I mean, I guess it's working, it's just taking time. I'm hoping this is going to be a shorter path. Actually, no, it's going to be a shorter path. It's a very short path at this point because it's already been done. So, it's just a question of supporting that kind of research.
What is your vision for the future of the Resonant Science Foundation? What vision do you have going forward?
There is many different things that I like. The vision is not so much for this. The foundation is hopefully become a community of learning that will be very significant. Already, we have almost 120,000 people taking the course after I published this paper, and I get some of these modules that describe the paper in layman term. Hopefully we can get millions and millions of people flowing through there. The Resonant Science Foundation has, hopefully the potential to become a very, very significant scientific source. And, it will go through iterations and all kinds of things. As well, I'm in the middle of considering all kinds of developments in terms of space exploration and so on. And so there is, partnerships with other organizations, that where the Resonant Science Foundation can become like the Starfleet Academy, for the public to get involved with space exploration and so on, and energy production and all this stuff. So the academic branch and educational branch is, of the foundation is really important, because this is how we bring the world to the next level, is by working together and gathering forces and really, participating and moving things to the next scale, which is just part of the natural flow of the rhythm of the universe. Yeah. So yeah, many things like that. So thank you, Jeff. That was a great question.
Thank you. Thank you. I'm so grateful for the Academy. I really am. It's so, you guys rock it. Bless you.
Thank you. I appreciate. Thank you so much. And it's really important for everyone to get involved, you know, and help as well. You know, we need help financially at the foundation, and in order to continue to do research and so on, it's really crucial. You know, there's the large institutions, but as well there is the each one of us individual make a huge difference. You know, becoming members makes a huge difference for us. Like the $5 a month, or anything you can afford a month, or you know, just one donation here and there, whatever, like whatever you can do makes a big difference for us. I wanted to mention that it's not it might be a trivial amount for you, and you might think it's a drop in the bucket and it's not going to help much, but for us it makes a huge difference. And we need all the help we can get at this point, because there's so much to do and so much to explore. And you know, more financial support we get, easier it is for us to get it done. How are we
Well,
doing on time? Wow.
well, yeah, it's amazing. We've already come to the end of our time.
Yes, maybe one more, and I'll try to be short.
Okay, because there is one that is kind of along the same lines regarding like 0 point energy development and technology. Angel asked, as an electrician, I often wonder, how will the conversion from weird devices such as plugs and lights, etc., be implemented to use 0 point energy?
Okay, I'm not sure the nature of the question. Can you bring her on?
Yeah.
I gotta. I got in trouble with that last question.
I think there's some pretty salient points. I mean, you know, it seems like to do fusion, you're going to need a singularity. But if you have a singularity, why not just harness the energy of the singularity? You know?
Exactly.
You can use the fusion for like transmutation or something.
Yeah, I mean, that might be useful later on for
Mm.
certain applications.
Mhm.
But then the power source is a self-standing, you know, vacuum energy translator, you know, on its own, right? The power supply is something different.
You know, I'm not sure if Angel is still on with us, because I'm trying to bring her up, but it's not doing anything. You know, she might have jumped off the call.
Okay.
I could go to another one.
No,
here.
ask me the question again.
Oh,
So
wait.
maybe I'll understand it better.
It looks like actually she might.
Oh, there she is.
It might be connecting here.
Hi, Angel.
And you need
You're
to
muted.
unmute.
Hi.
Hello, can you guys hear me?
Yeah.
All right, awesome. Yeah, I was just wondering, yeah, because like I said, I'm an electrician. I'm always at work running wire, and I'm always trying to figure out, like, you know, what are the devices like receptacles and lights? Like, what are they gonna look like in the future? Are they gonna just draw in the power like
Locally?
you know, wirelessly?
Yeah, in general, yes. Yeah, I would say that. And you could just, it depends if you want to network your device into, you know, wires to like, to a central energy source of your house, right? But it's not necessarily practical to have wires. So it's easier to I have a power source in every one of the device so that you don't have to I have wires everywhere. As well, it eliminates the vulnerability of the grid, which is a big problem. You know, the grid is very vulnerable to electromagnetic pulses from the sun and so on. It's kind of remarkable it's still holding. It's kind of mind-blowing, but I wouldn't push our luck, you know, like one big sun flare and we could lose power at least on one side of the earth, like all cities, like almost instantaneously, you know.
Okay, so
yeah.
is it similar to how like a router for Wi-Fi would be working? Like how it just concentrates the energy into the device and, you know, uses it that way?
No, each device would have its own router to space-time, you know. Each device is extracting energy locally. It's not connected from one device to the other that way. Now you can connect them that way as well, because now you have the mechanics to transfer information through wormholes, so you can entangle them, but they would be then, you know, quantum mechanically untangled, which is quite different than, you know, a Wi-Fi signal, but it's similar in some ways. You know, it's a frequency that's at the quantum scale, so it's way higher than anything we use.
Okay, yeah, I was just wondering, man, because yeah, I've been an electrician for about 5 years now, and like I said, I knowing of Tesla's work and your work, you know, and all your guys' work, it just makes me feel like I'm using primitive, you know, technology in a sense, knowing that we're capable of that. So yeah, thank you for answering that question. I appreciate it.
My pleasure. Yeah, you know, imagine a world where every device has its own power supply, that's extracting energy independently. And so that, you know, energy is no longer anything that you have to produce somewhere and transfer somewhere else. And so you have very little wires, either than in the device itself, to extract
So-
energy. Yeah.
Question though, like, so would it be more practical to tap into the grid since every device is already in every home, or would we have to do demolition to get rid of all of that stuff to implement the new technology?
Yeah, I mean, the grid will become irrelevant. Yeah.
Okay.
The grid will become irrelevant. It's not very efficient. It's very susceptible. You know, it's just not gonna. Initially, not. You know, initially we can continue to use the grid, and you know, power supplies can be put in term, replaced. Like the power supplies we use today can be replaced by, you know, vacuum energy technology, and then after that, you know, eventually, you know, every house, every car, every light bulb, every, you know, like.
Okay. Yeah,
It's
just
not-
one last kind of like add on to that. Like how soon do you see that being implemented?
it has to do with human evolution. It has to do about how much support it's going to get in the next few years. But it's only this kind of technology is right. It's there, as I said. So it's, you know,
Sorry about that.
that's okay. Are you on the job?
Yeah, I'm on a job right now.
Okay. So yeah, so it really is, you know, depending on how it gets supported in the next few years. But it has to happen in the next few years because humanity is on a threshold in which this technology must emerge at this time. You know, it's not like we have much of an opportunity to, like, you know, you know, take our time with this. It has to emerge very, very soon. And this is why the information is emerging now, because we need it. And so I'm sure I trust that humanity will make the right choices and support this and bring it to the world. I think that and all of the systems that are in place can actually thrive as a result. You know, there's everybody can benefit, all of humanity, from the individual somewhere in the middle of the desert in Africa to, you know, the corporations that are present today and so on. And you know, everybody can really thrive as a result. And the earth can regain health levels that are more acceptable, and eventually actually completely recuperate.
Awesome. I appreciate all of your guys' work. I'm so thankful. I'm wearing too, so I always try to explain to the guys, you know, how it operates and the 0 point field. And yeah,
Yeah.
I'll do my best to spread the word. Thank you guys.
Yeah, well, you know, just talk to them about what Maxwell's equations say. Go and see the Veritasium video on this. William, can you post it in the chat? And you know, think about it. Go and look up the paper from Feynman. It's easy to find, and
post it again.
maybe William can place it as well. And then yeah, it's important as an electrician, an engineer, and all this. And I wanna clarify as well that when I was talking about that earlier, I wasn't dissing the engineers or the physicists or anything like that. I'm just saying this is the result of some, you know, conventions that were put in that like confuses people, and we just gotta like clean up a little bit of these conventions so that we can find a solution that's productive for all of humanity. So, you know, it's really important from an electrician to, you know, an engineer, to a physicist, you know, to a student in physics, or to an average, you know, somebody that does like, you know, something completely different, you know, to understand, like even just to know that like charge actually comes from the field, you know, is useful because it kind of changes your optics, you know, and the way your radar is working, you know, when you're interacting in the world. You know, it might not be obvious to somebody that's not in that field at all, you know, but even just thinking about it, even if you're not in that field, is a really interesting thing, you know. And I think that it kind of like opens up neural pathways that that are useful.
Awesome. Much gratitude, Nassim. Thank you, William. Thank you to everybody. God
Thank
bless.
you.
And let's unify.
Yes, let's do it. Let's unify and
Much love.
and move to the next level. 2022 is the year, bro. Let's kick it in high gear.
Let's do it. I love you guys. Peace.
Take care. Okay, William. Sorry, I didn't let you speak much.
I was enjoying listening. It's yeah, I always learn a lot on every one of these Q&A sessions. It's always something new comes in, and I love that. So
Yeah, well, you know, it's really good to see that like people are interested, and that I'm hoping it's making a difference in their feeling about themselves, and their feeling about the world, and their feeling about, you know, our evolution right now, because sometimes it can look pretty grim out there. And although it is grim, there is light at the end of the tunnel, and it's really, really important for people to know that before they have you know, a near-death experience and see literally the light at the end of the tunnel. But you know, it's a good thing to know And I think that the evolution of our planet right now is really producing stressors that helps people like transcend some limitations they may have in their approach to life in general, and yeah, their understanding of themselves, and how incredible, miraculous it is that we're here, and that like as we as we go through all the trials and tribulation of our evolution, it is a beautiful path that lies ahead, with a complete transcendence of our current state of affair. We just have to hang in there and continue to put one foot in front of the other, and continue to support each other, and unify, and as well, unify inside ourselves to this grander, beautiful, incredible dynamics that we're embedded in, and experience it daily, even just if it's like 2 seconds a day, to just think about, oh yeah, I'm part of a field, and connect with the field and feel the field, and and all this, and then more we do it, more we feel it, and more we feel it, more we do it, and it becomes a over unity device. And that's really, really important right now. So until next time, may the vacuum be with you, may the field be with you, and thank you so much, William. Next time I gotta let you talk more because we have so many things to discuss.
We'll get a little bit further along on the biophysics paper, and we'll be able to
Yeah,
get
share.
some good discussion.
Yeah, exactly. Awesome. Thank you so much, everybody. Much love to everyone, and happy 2022. Blessings on our journey. Let's see you soon.